For this webinar, we're going to be talking about understanding the impact of human performance on workplace electrical safety. That's a long title. Basically, how can people mess things up? And what are the red flags, the warning signs that that is a potential, and how do we address them and help get rid of those as much as possible? So my name is Caitlyn Wininger. I'm electrical engineering by degree. I'm a certified electrical safety compliance professional through NFPA, and I've been with Herzig for a while now. So if you have any questions about electrical safety, please do not hesitate to either type them in the chat if you're watching live or reach out to us. Our contact information will be provided at the end of the webinar.
My name is Trey Toliver. Started with Herzig about 4 years ago. I've got my industrial electric certifications. I kind of handle a little bit of everything around here. I do a lot of our PPE work, a lot of our infrared work, all around just electrical safety.
Yep, got a lot of experience going on in this room. All right, so we're going to start off talking about a little bit about risk assessment procedures. We did a whole webinar on this topic. So again, if you want to go back and go to our YouTube channel, just look up Herzig Engineering, and there's a playlist called free webinars or free trainings, and you'll see one. A whole hour dedicated to risk assessments. But understanding how human performance impacts your level of risk is important, and depending on what work you're doing and things like that. And then we're going to dive in and do a closer look at Informative Annex Q. So that is an incredible article, or annex I should say, in the 70E that explains how human error kind of happens and some ways to identify that and avoid it, and build healthy habits to avoid some of the most common human error. So we'll be looking at that. We'll even get away from the slides and go to the NFPA itself and pull up some tables and references that I think you should spend some time studying. And then we'll wrap up with how to address human performance today. What are the factors that you can start to implement now to help avoid that in the future? And then of course, question and discussion. At the end, we always try to leave a few minutes to go over any questions that we didn't get a chance to yet. But as you're watching today, do not hesitate. Go ahead and use that question feature in GoToWebinar, that chat box. And as I see things that come up, if there's a relevant time to stop and just go ahead and answer it, I will definitely be trying to do that. So I'm looking off to the side because I keep checking to make sure that there's nothing else coming up. And Mike, yes, woohoo, we're very excited about it. So any suggestions you have, like I said, go ahead and throw them out there. All right, let's dive right in. Risk assessments. So what kinds of things are we looking at to make sure that our risk is, from the starting place, relatively low? Like installation, maintenance, things like that.
The work being done.
Yeah.
70B in general.
Yeah.
How the equipment is. Has the equipment been maintained? Has it been serviced? Everything been lubricated properly.
Mm-hmm.
When was the last time breakers were exercised?
That's a big one.
Yeah.
Yeah.
There's a lot of things we look at. Human error. Do we have the proper PPE?
Mm-hmm.
There's a lot of things not electrical related too. I like to mention, the environment you're working in.
Absolutely.
Takes a part of your risk assessment as well.
Yeah, a lot of these in one form or another of what we're talking about, it's covered in these 3 books here. So installing it right to begin with is kind of important.
Yeah.
Just a little bit. You don't want it to catch your building on fire or blow up on you the first time you turn it on. That's kind of important. But then, like Trey said, the reliability and safety requirements for electrical maintenance is another big factor. And then things about PPE and human error and things like that are more covered in the NFPA 70E, which is the one that we're going to be focusing on as we do for most of these trainings, because electrical safety in the workplace is such a big deal, such a big important topic. There's a lot of other safety topics that happen more often, like there's more incidents, but their severity tend to be lower. Whereas electrical safety, it only takes one electrical accident to kill somebody. Mm-hmm. It's not like several other options out there. Okay, so we're going to be looking at the 70E for the majority of this webinar. For those risk assessments in Article 110.3H, and I won't be reading off a bunch of article references to you, but it does talk about risk assessments and needing to make sure you comply with the various elements of them. So before you start work around potential electrical hazards, you need to identify them, assess the risk, and implement the correct risk control methods. And there's a whole hierarchy of them. Again, we had a whole webinar talking about them, but we're going to briefly review that today. So a qualified person should be able to do this, but not always do they. And they get distracted, they get rushed, they kind of just blow through this. They maybe know what the hazards are, you know, shock, arc flash, arc blast. They know it's there. Maybe they even know about PPE and boundaries, understanding how to keep people out of those hazardous areas. But then once they get in and they actually have to cross those boundaries and work, they may or may not be thinking through their risk assessment effectively. So identifying those hazards is step one, yes, but then what? Well, what are you doing? What type of work is needing done is a big part of it. Such as, okay, are you working energized, or are you doing troubleshooting, or can you turn it off to do the work? That should be your number one question, aside from what are the hazards? Can I de-energize this? And then condition of equipment, you know, we talked about that a little bit. Various hazards. So what other things in the workplace? We've got, of course, electricity, because that's what we're talking about. But what are some of the common hazards that you would see around that could affect people's risk?
Fork trucks.
Oh yeah, definitely. Yeah, other people.
Other people in general
yeah.
are, you know, a major hazard. Those who actually aren't qualified and don't understand the risk of electrical equipment when it's exposed and being worked on. Damp environments, or, you know, environment in general is a hazard. Inadequate lighting. You know, can't see very well. You're probably not going to work very well. You don't know what you're putting your hands on.
Other hazardous energy sources like pneumatics, hydraulics, compressed gas, things like that. Conveyor systems, pinch points. Yeah, I've heard too many stories where there's an electrical panel that's right next to one of their lines, their conveyors, and you're standing pretty much back to back with this line, and it has nothing to do with the panel you're working on. So it's not like you shut that off and the line behind you shuts off. That could turn on in any minute. It's like, okay, that adds some complexity for sure.
I always like to mention too, like working up in a scissor lift or up on a ladder, bus ducts, so you're up in a, you know, an aerial lift, or it's additional hazards you have to worry about.
Absolutely. And then the severity obviously can change as well. If you're looking at, you know, where you're just operating a breaker and everything's installed properly and all the coverings are in place, and there's not just little breaker blanks between you and the conductors, but actually, you know, the full and complete dead front is still in place, the severity of what you're facing is more than likely going to be lessened, because even if something goes wrong, that dead front, again, properly installed, properly maintained, all those wonderful things, no openings, is going to either contain or deflect, or at least limit the amount that you're exposed to, versus something that has something wrong with it.
Correct.
Right. And then the likelihood, okay, so that breaker example, well, if a breaker trips and you go turn it back on, but you didn't figure out why and help remove the chance of it tripping again, then you could be closing into a fault. So the likelihood of that going wrong is higher. There's a lot of scenarios and examples we can go through, and we have in the past, but just to get you started thinking. And then the emergency response plan. This is another issue for human error too. If we don't plan ahead appropriately and something happens, something goes wrong, what do most people do? Do they think clearly?
Oh, they panic.
They panic, yeah. It's got to get to the point where whenever you have something go wrong, you're not even trying to be in the moment and processing it. You just know this happened, this is what I do, this, that. It just becomes almost an automatic response, because every second that an electrical injury is occurring or has occurred could be the difference between life or death. How fast you can respond. So that's another human error side of things. You know, have you practiced? Have you talked about those things? Hopefully you eliminate human error on the front end though, and don't have an incident by planning out every job appropriately. So these risk assessments and job safety plans do need to be done before each job involving exposure to electrical hazards, and that's 50 volts or greater. So I got a question for you guys. We've kind of been introducing this idea, but let me just stop and ask, does your workplace even implement job safety plans for electrical tasks? And the options are yes. For every hazardous electrical task, 50 volts and greater, you have job safety plans. Fantastic. Yes and no. You know, maybe you have them, but you don't consistently use them, or you only use them for what you would consider high risk. And, you know, that's subjective sometimes. No, you don't use them, or you're just simply not sure. Maybe that's not something you're familiar with. So go ahead and click your response and click submit, just so we can see where we're starting with here as far as our audience. pretty even split so far as the first three options. Yeah, as these keep coming in, I'm not surprised to see which one's getting the most so far. Okay, I'm gonna give it just another couple seconds and we're gonna close the poll. So by a hair, the yes and no answer is taking the lead, that you have them, but you don't use them consistently, or maybe it's only the high risk tasks, the things that you think it's worth doing. And for those of you who are doing it for anything 50 volts and greater, you've got it, you do this before every electrical task. Fantastic, because that's actually what the 70E requires. For those of you who don't use them, maybe it's a learning opportunity, something that you can go back and look at what the 70E has to say about it and figure out how to implement that. They have sample job safety plan forms and job briefing forms in the 70E, so you don't have to start from scratch, okay? And for those of you who have them, cross-reference, make sure you're at least covering what they have to say. All right. So some things to be done as part of that job safety plan. Well, all of it still relates to risk assessments. Being trained for the task is a big part of that, part of being aware of what's going on.
Being trained, you know, a qualified worker is someone who's been trained for the specific task they're working in.
Yes.
So just because you're qualified for one piece of electrical equipment or working on one, you know, set of gear or whatever, doesn't mean you're qualified overall for all electrical tasks.
So wait a minute. If I hired a licensed electrician to work at a manufacturing plant, for example, they're not qualified?
Not necessarily, nope.
Okay, yeah.
We hire master electricians and they still go through 3 months of training with us to do our task.
Yep, it's not a blanket qualification. There is no such thing. It is very specific to the workplace and what you're doing.
Right.
Yeah.
Some other ones, risk assessments, you know, for the worker, as a worker, perform the task time and time and time again.
Yes, which could be a good thing, or it could be a precursor, an error precursor.
I've done it many times. I don't need to do my job safety plan or my risk assessment. I'll be in and out.
I know what I'm doing. I've done it before, been fine.
Famous last words.
Yeah, it'll be fine. That's a problem. That's called complacency. And I think a lot of people use complacency like it's a dirty word now, like, oh, he got complacent, she's complacent. Get over yourself. Everybody gets complacent every day. Let's just be honest about that. The difference is, whenever it comes to electrical work, you really can't afford to get complacent. Not that it won't happen, but you got to check yourself and be humble enough to admit whenever you are and address that.
Properly selecting and using the PPE is important too, and that's based off the risk assessment, which I think a lot of people leave out.
Yeah.
Caitlin, is you get the warning label, and that warning label has a minimum required PPE on it.
Yeah.
And people think, okay, that's all I need to wear at minimum, if they even wear that, right? But the risk assessment could determine that, hey, I got to wear some, you know, some more PPE. You know, I got to protect myself even more, or I'm going to be closer than an 18-inch working distance. And you know, that's a qualified employee should understand that and be able to properly select and don their PPE.
Right. Being tired or distracted is a clear error precursor. And I'm using that terminology because it's from the 70E Annex. We're going to be looking at that soon. But error precursors are things like, well, you notice that they're tired, they're yawning a lot, they're dragging, they're distracted. Maybe they have some big life event that just happened, you know, just had a baby and now they're first week back to work and they're tired because, you know, well, babies.
Keeping up with the 1-year-old at home.
Yeah, that can change how you focus on a day-to-day basis. And not to say that you should just start saying you're tired or distracted to get out of things, but just be real with yourself as far as when you may need another set of hands on that task. And respecting safe work practices. You know, you've got that go-to guy or gal. Everybody has one. They'll get it done. They'll get it done fast, right, the first time. Great, but do they do it safely? Oftentimes that go-to person doesn't because they've done it so many times. Everybody trusts them. Just let them do their thing. Okay, those are the people that a lot of the time end up a statistic.
Yep.
Okay, just because they've done it plenty of times before does not mean it's okay to do it their way this time. Okay, so that's one part. We're going to circle back on worker qualifications and the chance for human error in a minute. But some other things like we kind of talked about earlier, is it damp? A higher chance of electric shock event? Is there adequate lighting? other hazards, like forklifts, other people in the area would talk about that. The PPE itself, introducing additional hazards, I can argue ways around this a lot, but people bring it up. It's hot, it's hard to move in, you have no dexterity or very little, limited. Couple of things to think about that. Why are you doing it energized? Why do you have to wear it long enough and have such dexterity for whatever task it is while it's energized? Why can't you just shut it off, verify it's off, and then take the PPE off and get to work? Vast majority of the time I ask that and they just kind of scratch their head like, oh yeah, that's the thing. Okay, so clearly we're doing a lot of energized work we shouldn't. If it is truly justified, and we'll get in that in briefly just a minute, build in brakes. Have a second set of hands to rotate out if you need to, if it's a problem of heat. If it's a lack of dexterity though, getting the right size gloves can help. A lot of times people complain about that and their gloves are way too big for them. So there are workarounds, okay? But then another thing to consider in your risk assessment is the condition of equipment. And Trey, you kind of talked about this a little bit, but you want to summarize?
70B.
Yeah, there you go.
When was the last time your equipment was open, serviced, lubricated,
Yeah.
right? Hazardous associated with opening equipment that hasn't been, taken care of properly, equipment degrading over time. The last one, what is the age and general condition of the equipment? We've got a story of somebody who is brand new equipment. It doesn't always take a lot of people, determine it's old equipment that causes, the risk associated with. But we've had people, go in and brand new equipment just installed. The facility's been running for a month.
Yeah.
And there was an arc flash. I mean, it doesn't take new equipment. It's how the equipment's also been installed, which is part of the NEC as well. But
yes, yeah. So installing it right to begin with is a big deal, and then maintaining it over the years. Things go to the wayside sometimes, and it's only a matter of time before that comes back to bite you. So that's another part of human error, I guess, because you've got someone who installed it that maybe they shouldn't have been in charge of that job, that specific task, that enclosure by themselves. Maybe they weren't ready to do that. Because clearly they installed it wrong and it caused an arc flash for the next person who tried to access it. So very, very important stuff there. It's also important to realize there's a likelihood and severity ratio to look at. So yes, a lot of people think of one or the other. You look at a danger label for an arc flash hazard and you think, oh my gosh, that's super risky. Maybe. I mean, it could be. Depends on what you're doing. Depends on how you're interacting with it. Depends on how it's been maintained. Are you actually opening it, or are you operating something that is in normal operating condition? So your likelihood factors in too. Even if it's a remote chance, though, it's still undesirable. You should be taking action. And then there's other times where people are like, that's such a remote chance that it'll happen, or oh, maybe it happens all the time, but it's actually a low severity. So you got to you look at them both. Okay, don't negate one or the other. If you're anything other than the dark green desirable bottom left corner of this chart, whenever you think about your likelihood and severity, then we're implementing additional risk control methods. Okay, so let's just briefly, just like elevator pitch style, talk about what the risk control hierarchy methods are and their order. You want to start us off?
So elimination.
Yep.
Can we eliminate the hazard? Shutting off the equipment, but not always can you eliminate the hazard. So can you substitute the hazard for a less hazardous situation?
Yeah. Safer design. Yeah.
Engineering controls. Can we mitigate the hazards? Can we adjust the settings on breakers? That's not just going in and doing it. Have us come in and we can coordinate your system.
Right.
Awareness. Are we aware of the hazards? Do we know all the hazards? That's a qualified worker being aware. Okay. Administrative controls. And then last but not least, personal protective equipment.
Right.
Is that fast enough?
Yeah, that was good. That was perfect. So yeah, PPE is on there, and a lot of people jump to that, and you should, but it shouldn't be the only thing. That don't stop there whenever you think about risk controls. It's not just PPE. That's actually the least effective, but you have to have it every time. So narrowing in on the one that's most relevant to today's topic is awareness, being aware of those hazards and what to do with them. And like we said, even a licensed electrician at one company, if they jump ship and move to another organization, you don't know that specific equipment. You haven't been trained on their specific policies yet. And so until that happens and then your competency is verified, technically you're not qualified to be doing that work. And that rubs a lot of people wrong, but in reality, that's just what it is because of the definition of a qualified person. Not to say you can't become qualified easily enough, it's just you got to put in the time to get oriented with this new job. So one who has demonstrated skills and knowledge related to the construction and operation of electrical equipment installations and has received safety training to identify the hazards and reduce the associated risk. So there's 3 parts to it. You have to know the equipment you're working on. You have to have training on safety and how to reduce that risk, looking at those risk control methods. And you have to demonstrate those skills and knowledge through things like a field work audit, for example, someone going over and watching them work and not intervening necessarily, but just seeing that they know what they're doing and they do it safely without prompting. That's one thing. I think a lot of people, whenever the safety professional walks in the room, suddenly the gloves are on and the safety glasses are on and the hard hats get put on, but then they leave again and it's like all to the wayside. So without prompting, without being like caught out, they know that they're doing the right thing even whenever no one's watching. Okay, so if personnel do not meet this definition, they're not really considered qualified to be exposed to electrical hazards per the 70E, and therefore unqualified workers, whether they're electrical worker or otherwise, really are not allowed to open electrical enclosures or work near exposed energized parts. Okay, so got to make sure that that's taken care of. The other side of things, like we said, not always the electrical worker is the problem as far as human error is concerned. Sometimes people get into areas that they really have no business being in.
Yep.
And then you end up with injuries or even fatalities. So unqualified persons, specifically those who their job does not require them to do electrical work at all, still need to be trained. If they're going to be in an environment where there's electricity, I wonder where that would be, everywhere, then they need to be familiar with how to at least identify when a hazard is present. What does exposed even mean? And know what to do about it. Not them personally, but who to call, how far away to stay until it's completed, things like that. Okay, so let's dive into this idea of risk assessments and human error a little bit closer, a little bit more fine-tuned. Now that we've refreshed on what human error is, risk assessments are and qualifications, things like that. So for those risk assessments, it specifically says in 110.3 H2, human error being called out. Risk assessment procedure shall address potential for human error. It can have negative consequences on pretty much anything involved, the people, the work environment, and the equipment itself relative to those electrical hazards. Okay, one thing to note, top 3 actions leading to electrical fatalities, which oftentimes directly correlate with human error, is because they're working on or near energized conductors or circuit parts without the proper procedures in place. Okay. Contact with overhead power lines being the second one, again, getting too close without realizing it, poor job planning, human error. And lockout tagout procedure failure or safety controls removed. If you're not following LOTO the proper way, then that can lead to electrical fatalities. Again, all 3 of these, I would argue, have heavy impacts from human error. Okay. But focusing in on that on or near energized conductors or circuit parts thing, we have to make sure it's off before we work. And not everybody does. And that's another issue with people, because there's this culture still today in many places that, and I heard this quote recently even, you're not really an electrician unless you know how to work energized. Which there could be times that that's justified, but it's rare. I say you're not a real electrician, you're not qualified unless you know how to properly de-energize it. Because people skip steps. They throw the breaker, they get to work. They throw the disconnect, maybe they apply a lock and they get to work. Well, there's more to it than that. So let's just briefly summarize electrically safe work conditions here.
Do you want to go through the 8 steps?
Yeah, let's do it.
So it's step 1 of verification of an ESWC electrically safe work condition is determine all source of electricity.
Yep.
Okay. Number 2 is open all disconnecting means. 3 is visually verify the open disconnects. That's whenever feasible. Not always can we visually verify. 4 is release stored electrical energy, release or block stored mechanical energy, proper lockout tagout, triple check or triple test, live dead live, and then number 8 is ground if determined necessary. Okay, so all things are considered energized until verified to be de-energized through the process of an ESWC, which are these 8 steps.
Right, and that note is important. It's only done by qualified electrical workers, okay? That is truly essential. If you can get it to de-energized point, the chance of human error for electrical hazards hurting or killing somebody drastically drops. I mean, there's always a chance that maybe you didn't do this right. Maybe there was a secondary source that didn't get identified because you didn't determine all sources. You just looked at the obvious one and thought that's it, right? You didn't investigate further. It happens. People do that, which is why it's so important to do number 7 too. Verify absence of voltage, not just on the secondary side of that disconnect that you chose, but at the point of work where you're going to be sticking your hands. Make sure that workers are doing that. That can help address any chances that things got missed, but there's always a chance, the goal being electrically safe work conditions. If they're working energized, just know that the risk is much higher. The chance of something going wrong is much, much higher than if they were able to turn it off first. So that's why I'm using very cut and dry words. What if qualified worker can't establish an electrically safe work condition? Not won't, not doesn't want to, they can't establish an electrically safe work condition. Well, there's really only 2 reasons that would be acceptable. It's infeasible to do that work in a de-energized state, or it would cause additional hazards or increased risk by turning the equipment off. Okay, there's very few circumstances where either of those are even at play in today's world. But in case that is still a potential, they do have these exceptions. But keep in mind, people like to use the first one, especially infeasible due to equipment design or operational limitations, as a crutch. And they think, okay, well, we shouldn't turn this off because if we do, we'll lose the whole batch. Well, is there a way to plan it out to where there's not a batch of product on the line when you turn it off? Well, yeah, but that takes X, Y, Z. Sounds inconvenient. That's not infeasible. Okay, look up the definition of infeasible if you're confused. And then the additional hazard or increased risk thing, that's even more rare that I see people try to use it, but it is possible. I think of chemical processing areas or something that has a lot of really highly combustible material that gets airborne, like the combustible dusts. And they have strong industrial ventilation and air purification systems to help prevent it from being a hazard to the employees and or one little spark blowing up the whole building. Okay, fair. Maybe you can make this the statement that turning that off would cause an additional hazard or increased risk to anybody who has to work in that environment. Fair. But then if that's the case for either of those, it's truly infeasible or an additional hazard, you're going to have to fill out a permit. Only qualified workers, and you have to have proper justification, usually more than one person working, to help eliminate the chance of human error. You don't skip any steps with this. You take it very seriously. One note, you don't have to have a permit for testing, troubleshooting, voltage measuring. So the one time you can reach in equipment is with your meter, but you still got to have job safety plans and your risk assessment completed. Because even at that level of work, there is still risk. There is still potential for human error. Okay, so that was just kind of a brief refresh and summary of actually handful of topics that we've covered as a full hour itself. But I just wanted to set the stage a little bit because it's not just a matter of the people messing up that you have to worry about. You got to think about the other risk control methods. You got to think about who else is in the area, PPE, do you need permits, things like that. So it's not just about the worker doing the job. How are they going to mess up? Well, there's other things that happen too. So let's look at it. Human error in the Informative Annex Q. So first off, let me ask, do you have a copy of the NFPA 70E? And this will tell me a little bit, not just because I think you should get it, but it'll give me an idea of how familiar you might be already with the standards. So yes or no, do you have a physical copy, the NFPA link subscription, do you know how to get free access, or none of the above? You don't have it, but you know you need to get it. Just simple yes or no, and then click submit. Okay. And if you note, there are multiple ways to access the 70E now. Thank goodness. It used to just be physical copy years back, and
So is there a right answer to this question?
there's not a correct answer necessarily. It's what should you have though is yes, I would hope. But be honest, if you don't have it, well, we're gonna talk about it.
we're going to show you how you do get access to it.
Yes, right? Yes. We'll do that briefly and then jump in and pull it up ourselves. All right, I'm going to go ahead and close out the poll. So majority of people, yes. For those of you who have not figured out how to get access to it, I always recommend buying a copy. I like having the physical copy to flip through. Not everybody cares about that. You can get something called the NFPA link subscription. And there's a few ways to do that. You can go to the NFPA website and you can click purchase. You know, you type in 70E, look at the list of codes and standards. You can select purchase, either a physical copy, the handbook, whatever. And then next to that, you see the available in NFPA link, and that's a subscription service. For those of you who aren't ready to do that, if you scroll down the page a little bit to current and prior editions, you can select the 2024 version and then click this view free access button. Okay, and that's what we're going to be doing today. It'll take you to a different page, prompt you to log in. It's a free account. You just, if you already have it, type in your email and password and log in. If you don't, you can create an account in the bottom right. I would recommend doing that later if you don't already have one, but if you do, just go ahead and get that pulled up. So I'm going to go ahead and exit out of the slideshow and come to the free access online. So it'll pop up like this. We're going to scroll down to Informative Annex Q, Human Performance and Workplace Electrical Safety. And we're going to be spending pretty much the rest of the time going through this material. So one thing to note, it is the Informative Annex. It is not required to follow as per the codes and standards, but it is extremely helpful, especially whenever we talk about the level of risk you're facing. The chance of human error is always going to be a concern. And the more you can do to help address that and correct it beforehand, the better. Okay, so there's the nice little introduction, typical principles of human performance, you know, just calling out that people are fallible. We're not machines. We can make mistakes. In fact, it's likely. It's almost a guarantee. Nobody's perfect, no matter what your mama says. You know, having high levels of performance can be good, but if you're getting pressured to do more and more, that actually is not a good thing. That leaves you susceptible to more incidents. Okay, so avoiding it is partly just understanding the reasons mistakes occur and application of the lessons learned from past events. We could go on and on about stories of past events. I mean, there's plenty of them out there online that you can watch their video of them talking about it. One of them being Jason Brosen. He came and did an interview with me several months back, and we've got the video of that. And he's got a bunch of different resources out there nowadays too. He's very open talking about how he got to the mindset of, it'll be fine, I know what I'm doing. In fact, he was thinking in the moment, this is kind of risky, I probably shouldn't do this, but I need to get it done. How could I do it safely? But he didn't follow all the steps that probably should have been done. In fact, I know they should have been done. And he admits why. You know, it's a matter of, well, I'm trusted to do this work. I talked about it with my manager. They said, just work safely. You know what you're doing. You got this. Get it done. It's so easy to maybe even get our egos inflated a little bit. Not that that's necessarily happened with him, but just speaking from personal experience, even when someone tells you, you got this. Yeah, you're good. You don't need to worry about that. I trust you. That feels good. Let's be honest. That feels good. But on the other hand, you got to be able to set that line and say, no, I got to plan this out the right way, because even though I know what I'm doing, I can still make mistakes, and this is not worth that risk. Okay, get off my little soapbox there for a second. So information processing and attention, there's a whole section about how people process information, the amount of attention span they have, how they sense that there's something wrong, how they act in those situations, and what can change how we process that information and act accordingly. I'm not going to read this to you today, but I would highly recommend it because it gives a lot of insight on how we think and how we react, and how we can kind of retrain our brains to process information in a safer way, a more productive way, without leaving ourselves at risk and kind of overlooking things. So it talks about a lot a lot of the science behind it, but it's an easy read. Okay, it's written a little bit different than most codes and standards would be. It's just kind of a cool article almost to read about how this all works. Rules for human performance mode. We've got some general understanding, rule-based human performance, knowledge-based human performance, and then I think there was one more. Yeah, skill-based human performance. So understanding the different categories in that, and there's articles on NFPA about that as well, as far as understanding what specifically would fall under each of those categories. But I want to focus in on this error precursors area. Oh my goodness. Hello, scroll please. Q5. So there's a section about that, Q5 and Q6, human performance tools that you can use to help eliminate those error precursors. So a big one is task demands. So what are you doing physically, mentally? How much focus does it take? Do you need other people? Do you have higher risk, lower risk? Work environment also changes that. General influences in the workplace, not just thinking physical job conditions, but what is the culture? Do you have the kind of workplace where everybody just kind of laughs whenever you put your safety glasses on because, well, nothing's ever happened. No one's ever lost an eye here. Why are you worried about it? If that's the kind of work environment you're in, you're more likely to kind of go with the flow. And it's harder to stand up for yourself and have that discipline to say, no, I'm going to do it right because it's a habit. This is what I'm going to do. This is why I'm going to do it, and encourage others. It's hard to do that sometimes, but it is important. Individual capabilities, so that kind of goes to the qualifications, understanding their characteristics, and do they even have the physical strength or mental capacity to do these certain jobs, even emotional characteristics. Okay, so the idea of just having a newborn baby or a kid that just got hurt and was in the hospital, that matters. That impacts your chance of having human error. And then of course there's the general human nature. We get into routines, and if they're unfavorable, then that's a hard habit to break. Once you've identified some of those human error precursors, you can look at these human performance tools to help kind of re-guide, redirect, and create better habits. So looking at table Q5 is where I'm going to slow down a little bit in this. So on the next page, table Q5, it says error precursor identification and human performance tool selection. And that references Q5, Q.5 and Q.6 as well. Those paragraphs we were just looking at on the previous page. So let's walk through kind of how we can identify some of these error precursors, and then we'll shift over to the right column for human performance tools. So can you kind of explain the task demands, maybe go through some of those examples of error precursors for task demands?
Yeah. So time pressure, you're in a hurry.
It's a big one.
Money, time is money. Every time something's down, you're
Yeah.
losing money. So people, you're getting rushed to get stuff done.
Mm-hmm.
Repetitive actions are repetitive actions. We got it right.
Metonymy?
Yeah. Sure.
Monotony. Oh my gosh, that's the word.
Yeah.
Yes. In other words, you do it so much, you go into autopilot.
Mm-hmm.
It's like, I'm just doing the same thing over. It doesn't take a lot of mental effort. It's just, doing whatever task over and over again. Sure.
Lack of unclear standards. If there is no standards, there is no job safety plans. There is no risk assessment in place for your company. Okay. You're just really not paying attention. You're not following a standard. You're just kind of going in willy-nilly, hoping to get it done in time, and maybe under time pressure.
Maybe relying on past experiences and tribal knowledge a little too much, right? Or maybe there's an issue of simultaneous or multiple tasks. You're trying to multitask. Maybe you're doing this one thing, but you're kind of, again, the go-to guy to ask questions. And so you're doing this one thing, but you're constantly getting calls or radio questions or people coming up and asking you to look at a part while you're working. That's a problem, right? Maybe for them, because they're probably not wearing what they need to cross the boundaries and approach you, but it's keeping you distracted. You're trying to work on multiple tasks and assist with multiple demands. Yeah, there's a lot of things that could be a task specific thing, but then there's also the work environment, which the one I just talked about kind of goes in the first one here, distractions and interruptions. Maybe it's about another electrical task, maybe not. Maybe it's just other things in general. But what other things in the work environment do we see here?
I like that confusing displays or controls.
Yeah.
I think really, if you're not a qualified worker, you're not trained on that piece of equipment. If you're new, you're green, you're not going to understand those controls or that equipment and how it's placed together, how it was installed. So you're not qualified. You don't really know what you're dealing with.
Yeah.
Obscure electrical supplies or configuration, kind of same thing. Who installed this? This isn't what I'm used to seeing.
Yeah.
This is not right.
All those little shortcuts. Oh, I'm just going to do this to get it up and running, and then I'll come back and fix it later.
6 months down the road.
Nobody goes back and fixes it later. So stop doing that, guys. Okay. That's an error precursor too.
Changes or departures from the routine. Okay. Shift change is a big one. Shift change is a big one. And part of that, you have people coming in, you have people going out.
Yep.
You're in the middle of a task and you got new workers coming in that aren't really aware of the hazards that you've been faced with or what they're dealing with.
Yep.
So they're not used to that.
Yeah. And even just personality conflicts. I've given enough trainings and talked to enough people where sometimes the story results because maybe there's a little bit of conflict in the workplace. Maybe this one guy kind of is a little brazen and people don't like working with him. And so whenever you're partnered up with them, it becomes maybe a communication issue and you're not talking through the project like you really should be. And then somebody assumes one thing, and you know what they say about the word assume. Well, someone else assumes another situation is at hand and it conflicts, right? And so the personality side of things does matter as well. Individual capabilities goes into being qualified. If you're not familiar with the equipment or if it's the first time that you're performing that task, be extra cautious. And I think the statistics show that that is still the case. People aren't super brazen about equipment they've never opened. There's always those outliers, of course, but thinking about just in general, the statistics of new people versus those who've been on the job a decade plus, if it's the first time they're doing the task, they're slowing down, they're thinking about it, they want to make sure they do it right, versus someone who's been in there a million times. Okay, so lack of knowledge, maybe a faulty mental mode, new techniques not used before. Imprecise communication habits are another big one. Maybe you have systems in place, but an individual kind of cuts corners as far as letting people know when and what they're doing. Lack of proficiency or experience. Not good problem solving skills, which electrical work, I feel like the vast majority of the time is spent troubleshooting, at least for those in a work environment, not necessarily the new constructions, but in a manufacturing or a business or a hospital or whatever. They're in problem solving mode like all day, every day. And if you don't have a good way to approach that, then you miss things very easily. And then human nature. So we've kind of touched on this already, but let's expand on that. What kind of human nature things totally outside of the workplace, but still absolutely can affect?
Your real life outside, work is not our entire life. So it's whatever happens outside of work that gets brought to work really affects your day-to-day jobs.
Absolutely.
And not only on yourself, but others. People, you're working with somebody who comes in and they've had a rough day or something happened last night, and then now you got to help deal with that, and the stress they bring on affect you and your job.
Right.
It all kind of goes together.
Yeah, and then taking it into the workplace, there is workplace stress too. I mean, frankly, that's probably one of the biggest factors in people's lives as far as their level of stress. Habit patterns, a problem that I see is a lot of new workers, they've just been told how to do it and how to do it safely, and they're trying to, and then they see everyone else with their own little shortcuts and habits that are not good a lot of times, and they think, well, why am I doing this? I need to figure out a better way like they did. They think it's a better way because they're still standing there working for now. There's a lot of assumptions made: complacency, overconfidence, inaccurate risk perception. There's so many times I'm talking to people and they talk about electrical work as if it's just no big deal, as if it's just part of the job. That's what they're here for. And yes, that's true, but they're so lackadaisical about it. It is what it is. It's no big deal. I'll go up and barehand this, no problem, because I'm wearing H shoes. What are you doing? That's the wrong mindset, because you clearly have a skewed risk perception. Okay, so a lot of those can go into it. That's not a complete list, of course, but a lot of it comes down to human nature and how you're going to process that information, or how that worker is going to process that information. Again, going back to earlier in Informative Annex Q, talking about how that works. So how can we help address this? What human performance tools, is what they're being called, can help identify and or get rid of some of those common error precursors? And the first thing we see is just a proper job briefing. So doing your job plan and talking about it ahead of time, every time, make it a habit. Use those hierarchy of control methods, assess those risks in a realistic way, not in your biased, I've done this before and it's been fine manner, but if it did go wrong, what would happen? Think about it in that way. Do those job plans and brief with everyone involved. But just talking about it doesn't always help either. People's attention spans are remarkably short nowadays. And so talking through it, great, maybe they understood it in the moment, but then they got distracted, and 5 minutes later when they're actually starting the task, they're like, ooh, I don't remember, what did they say about this? It happens. So review it, have it on hand, make it available for people. Okay. Doing a job site review, not just in the moment whenever you're about to do the job, but maybe at the beginning of each day, you kind of walk around, look at what are you about to be doing, and then before each task, do your specific job plans. Look for other situations that could arise. Again, like the forklifts driving around, are you in an area where that's going to happen? Is there public traffic? You know, there was one time I had an audit where I was going through and talking to the workers, and they were like, yeah, this is kind of a weird week. We've had a lot of people touring our facility because they had just been bought out by a major corporation. And so all the bigwigs were walking around looking at the place. And that added hazards because everybody was told to work a little bit differently, work a little bit safer, and nobody was familiar with those policies, even though they'd been around for so long. And so it was kind of interesting because technically they were working safer, but they were also concerned and nervous about these bigwigs walking around, that even though they were working safer, they felt less safe because they were nervous and dropping things and, you know, just overthinking things. Yeah. So I digress. There's a lot of things that can impact this. Talk about it ahead of time, give people realistic expectations, and then do a post-job review as well. What went right? What were your close calls? Hopefully they're only ever close calls. And how do you remove the chance of those happening again? And then there's this idea of doing a peer check. So not necessarily does it have to be the safety manager or the supervisor every time, but somebody working with you, and you can just have that real conversation. Hey, you know, don't forget to do this. Hey, next time, I think it would have been safer if you had approached it this way. Having a peer review your work gets another set of eyes, not just to make sure it was done right, but that you did it safely. And then of course there's those procedures. So you want to talk about procedures a little bit, read through that and we'll talk?
Yeah. The step-by-step procedure, read, outcome, understand. Okay, so circle the task to be performed, check off each task as it is completed. So kind of having a list of what you're going to be doing. That's probably part of your pre-job briefing as well, is getting a list together. Here's what needs to be done. Here's the order we're going to do them. And then as you do that, as you go through the tasks, the procedures, check them off, mark them down, make sure you have everything done, you know, or remembering to, hey, okay, we finished this task, I got to take this tool out, remembering, you know, list of all your tools.
Even the simple things, yeah.
So before, or when you're done, I guess, you can make sure you have all your tools out of that equipment before you re-energize it. Otherwise, that's a potential arc flash hazard as well.
Yes.
Just more human error.
Well, and as you do the step-by-step procedure and you read it out and you check it off as you do it, or have someone else check it off, that could also be a peer review moment. With each step, yes, you said you did it. Did you do it right? Before you move on, you have to verify that it was done right every time. Because one of those steps being done even just a little bit off in electrical world, that's a big deal. If you don't have another person to go through that with you, you can still do that yourself, which does take some planning because you have to figure out what those steps specifically are and what they should be, not just to get the work done, but to do it safely. So if you don't have a second person, you can do the STAR method, stop, think, act, review. So it's self-check. You're basically talking through it, but with yourself. Verbalizing it, getting it out in the world, using your words, not just stopping and thinking about it, but saying it, engages a different part of your brain. And it talks about that in Informative Annex Q a little bit too. it really does make a difference. You know, I think in college and on the work site even, but more often in college, in the library, you see people like whispering to themselves. It's because it engages a different part of your brain. You're more likely to process that effectively, clearly, and remember it in the future if you say it and write it rather than just think about it. Okay, so stop. Before you do anything, stop and make sure you have what you need. Think about it. Talk about it to yourself. Make sure that it makes sense. Act on that while you're verbally confirming that you're doing what you've stopped and thought about, and then review that you didn't miss anything before you move on. Okay, before, during, and after each task. Another option is three-way communication. So you do that self-check verbalization, but instead of just talking, I'm doing this, it's more like they're telling you the step, you're confirming you're doing it, they're confirming that you did it right. Again, that three-way communication. And it could be with a radio. It doesn't always have to be a second person standing right there, or it could be on a phone, okay? In fact, there's a lot of times, especially in like switching procedures, that's the occurrence, because you can't have eyes on every piece of equipment as you're turning it on or off. And so you've got somebody stationed watching the equipment while someone else is in the electrical room, and you're talking, you're doing that three-way communication. We're ready to turn on line 5. Ready to turn on line 5. Yes, line 5's ready. Turning on line 5. You know, you go back and forth until it is on, and then you confirm line 5's working. Line 5's working. Yes, line 5's working. Great, you're done with that task. Why do it multiple times? Well, make sure you heard them right. You know, you don't want to be like, don't turn it on. Turn it on, okay. Because didn't get caught. You confirm. Okay. Stop when unsure.
Yes, if you come across a situation that you're not sure of, you know it's not part of the normal procedure, the process that you're supposed to be following. Don't just try to assume I know what I'm doing and I'm gonna make it work and all right, we'll just figure it out as I go. Stop and think. You know, stop, do that self-check, that verbalization, that STAR, that stop, think, act, review. Go ask for some help. Reach out. It's always best to ask and do it the right way the first time, then assume you know what you're doing, and then human error.
Yes. Yeah. If you have any questions about it, and maintain a questioning attitude, we keep using this word assume, but it's true. Don't assume anything. Don't think you already know what the answer is without stopping and considering the other options, the other possibilities. Okay. And then there's this idea of flagging and blocking. So identify or flag equipment and controls that will be operated, prevent access, in other words, block that equipment and controls that should not be operated. So you avoid the chance that somebody's working on the wrong thing, or turns off the wrong thing, or turns on the wrong thing. Flagging and blocking. There's a lot of ways that you could implement that. And again, I would go back to the actual article reference in Informative Annex Q that discusses this option for more detail. Okay, so there's a really good summary of those error precursors and human performance tools to help identify them and remove them. Getting into those habits of communication, planning it effectively, and stopping, thinking, you know, before you do each task, during each task, and then review it with yourself or somebody else before moving on every time goes a long way to help eliminate a lot of these error precursors, or redirect them, I should say, because they still exist, but it helps keep them from becoming an incident. Okay, so there's more information on each of those in the Informative Annex Q. Like I said, you know, flagging, blocking, lookalike equipment, you don't want to get confused, stuff like that. Okay, so that's Informative Annex Q in a nutshell. I highly, highly recommend you go back and read this 4-page section, and you know, half of that page is one that we already just went through, or I guess 5-page, whatever. And make sure that you understand how to identify if somebody could be more likely to cause human error. It's going to happen to everybody, but when is it more likely, and how to prevent that? How do you establish some of those procedures to prevent it? Okay, so I am going to, how can I, there we go, minimize that so I can get back to the slideshow. And we're going to come back down where we were. Okay, so just to summarize what we just covered, Error precursors include the task demands, the work environment, each individual and their qualifications, and just human nature in general. And then those human performance tools.
Pre-job briefing, job site review, post-job review, the procedure use and adherence, self-check with verbalization, so that's that star,
Stop, think,
yes.
act, review. Yes.
Three-way communication, stop when you're unsure, ask questions, do it the right way the first time, and then flagging and blocking.
Okay, so that gets you started, hopefully, to advance your risk assessments and address that human error. Okay, so some action items for you today addressing that human performance issue. Well, first off, you got to be able to identify what the hazards are to start your risk assessment. So have a study done to identify the arc flash and shock hazards. Make sure it's done by someone who knows what they're doing, a licensed engineer that has that specialty, so that you can actually start performing your risk assessments effectively. You don't want that to be a guessing game. And then train your employees, both electrical and non-electrical, about the hazards, how to identify exposed equipment, distances to stay away, and then take it a step further for your electrical workers on how to work safely. This third one, so those are kind of steps to start, but then this third one is something that you can be kind of doing in conjunction with, or in parallel, I should say, with those initiatives. Get more effective job safety planning steps, procedures in place using those human performance tools. Just having a checklist to go through is great, but that's not all. You could be utilizing that three-way communication or that STAR method or the peer review method in addition to completing that form that you guys have created, or maybe you need to add to it. Okay, so looking at table Q.5 can give you some good ideas and examples. And then verify that your qualified electrical workers are actually doing what they're supposed to. So regularly retraining and auditing QEWs kind of keep each other accountable. We forget things, we become complacent. Again, not a dirty word, it happens to everybody, but whenever it comes to electrical work, it's not something you want to just overlook and accept as part of, human error. Okay. Make sure they're doing what they should be doing and retrain as needed. Okay. If you need some help, we can certainly assist, especially with those arc flash studies, as well as just electrical safety program development and talking about training and effective methods for that, doing maybe an audit on your equipment, because condition of equipment is a big part of risk. Writing your program, there's all sorts of things that we can help with if you need it. But we have covered a lot today, and we've pretty much taken the full hour, so I apologize on that. We got off on a couple tangents there, but I think it's still very important stuff. We have to understand what's required and why to achieve compliance and, more importantly, safety. So I'm going to go ahead and open it up for Q&A. So if anyone was holding on to questions during this training, go ahead and use the chat feature to type it out. Or you can always email us after the fact or call the office and we'll get you the answers to those questions. Thank you so much for attending today. If you're done, you're good to go. Otherwise, we'll stick around for those questions. Thank you.